Hi everyone, in Algebra 3 today we're going to be going over the new material in lesson 72, which is on one side plus two other parts, and it's also called the law of sines. So what the one side plus two other parts means is that if the length of one side and the measure of two other parts are known, it is possible to solve for the measure of the missing parts. So if you have one side plus two other sides, or one side plus two angles, or one side plus one angle and one side, we're able to solve for all of the other missing parts. We cannot solve for missing parts if we do not know the length of at least one side. So it has to be one side plus two other parts. A triangle that is not a right triangle is called an oblique triangle, and any oblique triangle can be solved if one side and two other parts are known. So this is for not right triangles. The law of sines is going to be this. We will consider that an angle and the opposite side angle constitute a pair. So one angle and the opposite, that should be opposite side, constitute a pair. So this would be B and this angle, A in this side, and then C in this side. So, and this is going to be the ratio that is set up for us. So it's going to be A over the sine of angle A equals B over the sine of angle B equals C over the sine of angle C. We can also solve any triangle of three parts. One must be a side are known. If two of the parts constitute a pair, we can use the law of sines to solve for the missing parts. So we're going to be using the law of sines to solve for our missing parts. So what we're going to do is I am actually going to go through an example with you before we actually go through the problems in your lesson. So for this one, what we're going to do is we're going to start off by just listing out all of our ratios. So I'm going to start with, let's just start with x over b. So this would be x over the sine of b is equal to 7 over the sine of 23 equals 10 over the sine of A. So it's just side over sine of the angle, side over sine of angle, side over sine of angle. Now all we have to do is solve. So I'm going to start by solving for A. So I'm going to cross multiply these two equations here because there's two unknowns over here. So that would be 7 times sine of A equals 10 times sine of 23. And then we're going to divide both sides by 7. And that would be, so 10 times 23 sine equals, and then divided by 7 gives me 0.588. So I have sine of A is equal to 0.558. But how do I get that A by itself? Well, I actually have to use the inverse of sine. So now that I have my ratio in here, I just have to hit second sine. And that tells me that the angle, so anytime you're solving for the angle, you're going to have to use the inverse of your sine. So my angle A is going to be equal to 33.93 degrees. Now to solve for B, I'm going to just use the fact that a triangle adds up to 180 degrees. So I have 180 minus 23 minus 33.93. So 180 minus 23 minus 33.93 gives me that angle B is going to be equal to 123.07. Now what we're going to do is now I can use these first two fractions to solve for x. So I'm going to cross multiply. So that would be x times sine of 23 equals 7 times sine of 123.07. And you're going to divide both sides by sine of 23. So now I'm going to do, okay, so 7 times 123.07 sine equals, then divide that by the 23 sine equals, and you get x is going to be equal to 15.01. And that is going to be how your law of sines is going to work. So now what I want you to do is I want you to actually attempt numbers 7 through 19. 7 through, I think it's 19. And then you can unpause this video, and that should give you a good start on your stamp for this lesson. But when you unpause the video, you should have attempted the problem so that I'm not just doing them for you, you're actually learning from them. So what we're going to do is we're going to start on number 7. So for number 7, I'm going to set up my law of sines. So I'm going to do A over the sine of angle A equals, let's do 8 over the sine of 30 equals m over the sine of 40. Okay, so I'm going to start by cross multiplying these last two fractions, and that would be m times sine of 30 equals 8 times sine of 40. Then you're going to divide both sides by sine of 30. Okay, so 8 times 40 sine equals, then divided by 30 sine equals, and I get that m is equal to 10.28. Now actually, before I even started this problem, I could have solved for a, because a is going to be equal to 180 minus 40 minus 30. So I actually didn't even need to use my trig functions for that. So a is going to be equal to 110. Now I'm going to solve using my first two fractions right here, cross multiplying. So that would be 8 times sine of 110 equals a times sine of 30. Divide both sides by sine of 30. So we'll do 8 times 110 sine equals, then divided by 30 sine equals, and you get that a is equal to 15.04. Okay. And now I want you to also, I hope you have also attempted number 8 as well. So for number 8, we're doing the same thing. It's the law of sines. I'm going to start with, let's do, well, we can actually solve for b before we actually set up our law of sines. So b would be equal to 180 minus 130 minus 22. So 180 minus 130 minus 22 would give us b is equal to 28. Okay, so that's my first answer. Then I'm going to set my law of sines. So I'm going to do b over the sine of b. So b over the sine of 28 equals 12 over the sine of 130 equals c over the sine of 22. I'm going to first solve for b, so I'm going to set up these two ratios, cross multiply them. So that would be b times sine of 130 equals 12 times sine of 28, and divide both sides by sine of 130. So we're going to do 12 times 28 sine equals divided by 130 sine equals, and we get B is equal to 7.35. And now for C, you're going to set up your ratios for this last one, which is going to be similar. So it's going to be C times the sine of 130 equals 12 times sine of 22, then divide by the sine of 130. So 12 times 22 sine equals divided by 130 sine equals, and that would give you C is equal to 5.87. Okay, and that would conclude the new problems from that lesson. But you should have also attempted number 9 as well, because I want to just go through some of these problems with you. So for number 9, it's already in the correct standard form. And now what we want to do is we want to actually take the square root of each of the denominators. So for x, I take the square root of 16. And then for y, I'm going to take the square root of 25. And that will give me how far away on the x-axis and how far away on the y-axis I need to go. So 1, 2, 3. So the square root of 16 is 4. So away from the origin, I'm going to go 4 spaces. Square root of 25 is 5, so I'm going to go 5 spaces away. And then all you have to do is connect the dots. So mine looks kind of like a circle because it's not a very good ellipse. But this would be 5, and then this would be 4. Okay, it has to be, oops, you couldn't even see that. So you would have to have it in this format in order for you to be able to graph that ellipse. Now for number 10, we have to put it into that last form that we just saw. So what I need to do is I need to divide everything by 64. So that'd be 4x squared divided by 64 plus 16y squared divided by 64 equals 1. So 64 divided by 4 is 16, so that would be x squared over 16. 64 divided by 16 would be 4. So y squared is 4 equals 1. You can take the square root of that, the square root of that. So 1, 2, 3, 4. So 4 away, 4 away, 2 away, 2 away. And then graph your ellipse. And that is your result for number 10. So putting that in standard form, which does look like double intercept form, is what you have to do. Okay, so for number 11, a biologist believes that the lengths of the squirrel's tails normally distributed with a mean of 8 and a standard deviation of 0.25. If she is right, what percentage of squirrels have a tail whose length is between 7.6 and 8.2 inches? So this is what a normal distribution is going to look like. It's normally distributed on either side of the mean, which is 8. So what I need to do is I need to find the percentage that's going to fall below 8.2, and then the percentage that's going to fall between 7.6. So if I can find this, what falls below here, and then what falls below here, I would find the difference between them to solve for this percentage. So what we're going to need is that standard normal table. We're going to calculate the z-score for both, which is x minus the mean divided by the standard deviation. So for the first one, the z-score is going to be 7.6 minus 8 divided by 0.25. And the second one is going to be 8.2 minus 8 divided by 0.25. So 7.6 minus 8 divided by 0.25 gives us negative 1.6. Then 8.2 minus 8 divided by 0.25 gives us positive 0.8. So now what I'm going to do is I'm going to go to my standard normal table, which tells me the percentages that's going to fall below each of these. So for the first one, I'm going to go to negative 1. Yeah, I guess you can't see that. First one, I'm going to go down to negative 1 and then over to 0.6. That means that percentage is going to be 5.48. So the percentage that falls below is 5.48%. Then for the second one, the 0.8 go down to positive 0 over to 0.8, which gives you 78.81%. And you're trying to find the difference between the two. So the difference would be 78.81 minus 5.48%. So 78.81 minus 5.48 gives us a percentage of 73.33%. Okay, so we had to use our standard normal table on that one. We had to use that standard normal table for that one. So now what we're going to do is we're going to move on to number 12. So for number 12, we are solving for a matrix. And this one, what you wanted to do is you start the top left times bottom right, and then you subtract top right times bottom left. So for number 12, I'm going to have a minus 1 times a minus 1 times 2 equals 4. If I multiply this out, I get a squared minus a minus 2 minus 4 equals 0. So I have a squared minus a minus 6 equals 0. And that actually factors out evenly because a minus 3 times a plus 2 equals 0. So that means I have two answers. I have a is equal to 3 and then a is equal to negative 2. And that concludes number 12. Now looking at number 13, we have find the coordinates of the focus and the vertex and the equation of the directrix for the parabola y equals negative 1 over 8x squared. Graph the parabola. So I know that this is going to be a negative parabola. I am normally given the equation y equals 1 over 4p times x minus h squared plus k. If you notice in this equation, though, there is no h and there's no k, which means that h is going to be equal to 0 and k is also equal to 0. Then I can find out what p is equal to by setting 1 over 4p equal to negative 1 over 8 and cross multiplying that. So that would be negative 4p is equal to 8. So therefore p is equal to negative 2. So these are your variables, and we can use that to solve for the focus and the vertex. The vertex is at h comma k, which means that our vertex is going to be at 0 comma 0. The focus is always at h comma k plus p. So that means my h is going to be 0. My k plus p would be -2. So now I'm going to graph this, and then I'll come up with the directrix. So my vertex is at 0, 0. My focus is at 0, -2. My parabola faces down. The distance between my vertex and my focus is the same as the vertex and the directrix. So if this is 2 spaces down, my directrix will be 2 spaces up, which is going to be a horizontal line which goes through y is equal to +2. And for this problem, they wanted you to graph the parabola, which I did, find the coordinates of the focus and the vertex, which we found here, and to find the equation of the directrix, and that's it. So that concludes number 13. So you have to do some memorization on that one, just like you normally do on problems. And then moving on to number 14. So for number 14, the reflecting surface of a parabolic radar dish has a shape formed when the parabola is y equals 1/50x squared is rotated about the axis of symmetry. If the measurements are in feet, how far from the vertex should the receiver be placed if it is to be placed at the focus? Well, I need to find out what the vertex, where the vertex is and the focus is. So again, using my equation, y equals 1/4p times x minus h squared plus k. I notice that there's no h and there's no k from this equation. So that means h is 0, and then again k is 0. Then I'm going to solve for p by setting 1/4p equal to 1/50. And for cross multiplication, I get 4p is equal to 50. So p is going to be equal to 12.5. So now we're looking for the equation of the focus. So if my graph is going to start at the origin at 0, 0, because vertex, remember, is h, comma, k, which would be in this case 0, 0. My focus is at h, comma, k plus p. So if this is my vertex and my parabola is going to go like this because it's positive, k plus p would be 0 plus 12.5. So that means that my vertex, or the focus, is going to be 12.5 feet away from the origin. So your answer is just 12.5 feet. So you just needed to calculate the distance away from the vertex, which was 12.5. Now for number 15, I'm going to sketch this graph. So I'm going to start by just flipping this around. So I'm going to change the y to the exponent. The 3.5 is going to be your base, and then x is going to be your number. So for number 15, I have x is equal to 3.5 to the power of y. So when I plug in my y values, I'm going to plug in -1, 0, and 1. Anything to a negative power makes it into a fraction, so it'd be about 1/3.5, which is about 1/3. Anything to the 0 is 1, and then 3.5 to the 1 would just be 3.5. So when you graph this, you're going to go over about 1/3 and then down 1, over 1 up 0, and then over 3.5 up 1. So your diagram should look something like this on number 15. Now moving on to number 16, which we are asked to write the equation of the sinusoid as a sine function. Okay, so I have that diagram here. So to write this as a sine function, what I have to do first is I have to find the midpoint between the top and the bottom numbers. So the midpoint between the top and the bottom is going to be top plus bottom divided by 2. Then for B, it's going to be the top number minus whatever I get for the bottom number. And then for C, it's going to be the length, 2 pi divided by the length of the period. So for the length of the period, we're going to calculate it like this. It starts at negative 3 pi over 2, circles down, circles up, and ends at 5 pi over 2. So I'm going to just add those two lengths together to find the length of the period. So again, it would be 3 pi over 2 plus 5 pi over 2. Okay, so now if you look at what I have so far, I have top plus bottom divided by 2. So that would be negative 6 divided by 2, which is negative 3. And then for the amplitude, it's top minus the middle, which would be 2 minus negative 3. Then if I do 3 pi plus 5 pi, that's 8 pi. So 8 pi divided by 2 is 4 pi. So 2 pi divided by 4 pi. The pi's would cancel and you'd be left with 1/2. So far my answer is going to be y is equal to negative 3 plus 5 sine 1/2. And now we're going to do the phase shift. So currently you can see on your diagram that it's sloping up at pi over 2. We want it to slope up at the origin. So that means we have to shift this whole graph over to the left, pi over 2. So that means that we would go x minus pi over 2. Okay, and for your C, you should never have a pi in there. It should always just be a fraction or a whole number. Okay, that's number 16. Now number 17, it says to write the equation of the sinusoid whose graph is a sine curve with a center line at y is equal to negative 10. Okay, so for 17, they give us that our center line A is going to be at negative 10. Then they say the amplitude, which is always B, is 20. Then they say the period length is pi. So that means we're going to do 2 pi divided by the length of the period, which they give us as pi. Notice that the pi's do cancel, so that simplifies to just 2. There is no phase shift, which means you have everything you need for your answer at y is equal to negative 10 plus 20 sine of 2 theta. So again, there's no phase shift, so there's no d. But all you did was plug in all of the values that they give you. Now for number 18, there are 2 parts. We want my answer of 18A to look like B, and then the answer B to look like A. So the first thing that I recognize is that my whole number is negative, which means that goes to the left of the origin. And then the positive 6 means it goes up. So it goes to the left 8 and then up 6. So that means you're in quadrant 2. So 8, 6, you're going to solve that for the hypotenuse and then also the angle. Use Pythagorean theorem to solve for the height. So h squared equals 8 squared plus 6 squared, which gives us h squared is equal to 100, which means that h is equal to 10. To solve for the angle, you use inverse tangent of opposite, which is 6, over adjacent, which is 8. So that would be 6 divided by 8 equals, and then second tangent. And that would give you an angle of 36.87 degrees. But because we're in quadrant 2, we need to subtract that from 180 because we need to know the distance from 0 degrees. So 180 minus 36.87 will give us 143.13. So my answer is going to be 10 CIS 143.13. Now for part B, we just have to expand. Remember that CIS stands for cosine plus I sine. So we're going to expand this to be 3. Well, first of all, negative 420 is greater than 360, so I'm going to add 360 to that. So 420 minus 360 would be negative 60. So this would be 3 cosine of negative 60 plus I sine of negative 60. Negative 60 degrees would be in quadrant 4. The adjacent's 1, hypotenuse 2, opposite is negative root 3. So the cosine of that triangle is going to be positive 1/2. And the sine of that triangle is negative root 3 over 2i. And then all you have to do is distribute the 3. So your result would be 3 over 2 minus 3 root 3 over 2i. Okay, and that's part B of that problem. So converting from rectangular to polar and polar to rectangular. The last one we're going to do is number 19. And for this one, what we need to do is we need to multiply the outside and then add the degrees together. But I think that this is probably not written right. Okay, wait. So that would be 6 times 3, which is 18. Add the degrees. 3 pi plus 2 pi would be 5 pi, and 5 pi over 5 would just be pi. So now we have 18 cosine of pi plus I sine of pi. What you should remember is that pi is equal to 180 degrees. So on the unit circle, it would be to the left 1, up 0. Cosine is always equal to the x-coordinate. Sine is equal to the y-coordinate. So the x-coordinate is negative 1, the y-coordinate is 0. So that means we have 18 times negative 1 plus I times 0. Well, if you distribute the 18 to that, you would just get an answer of negative 18. So this one you have to use the unit circle again because it was equal to just pi. Okay, and that should conclude you getting started on lesson 72. Hope you guys all have a great day. Bye.